Okay, just to review, this is the key insight from the last video, where if you ever switch the order in which the bounds appear, you must make the total area. I'm sorry, the signed area. You must change the sign of the area from whatever it was. If this one was positive, you must make it negative. If this one was negative, adding another negative out front does in fact make it positive. So just keep that in mind. Switching the bounds, switching the order of the bounds changes, adds a negative sign out front. So let's get into this new property we're going to talk about. Now, some of you may even remember this from geometry, possibly. But how does it work if you have different line segments and you're adding them? Let's see. So let's say from A to C. From A to C, let's say that's 5, and then from C to B, that's 3. Well, what would you do if you know this is 5 and this is 3? What is A to B? Well, that would have to be 5 plus 3, because C is just a stop you make along the way. And so if you go 5, stop at C, and then continue on your way to B and get to 3, then you've gone a total of 8. That's not so bad. Well, let's say here from A to C. Now this is a tricky one because A to C is going which direction? This way. So let's make it -1. Okay, and then from C to B, let's make it 20. All right, what is the distance from A to B? Well, you take, how would you figure that out? Well, and I'll put the negative out front because that tells us which direction we're going, right? Because, yeah, you would subtract. You subtract where you end up. You subtract where you started from where you end up. And that gives you've gone -1. So what you do, again, you just add them up. That's 19. Okay. How about like this? From A to C, let's call that 8, and C to B. Let's say that's 7. Obviously not to scale. All right, so from A to C is 8. From C to B, again, if we're starting at C, what that means is we have to put a negative out front, and because we've gone backwards. And so then when you do and you get it up, this distance would have to be 1. And does that make sense? 1 and a distance of 7 going this way, that makes 8, yes. 1 here and a distance of 19, that does make, in fact, the big 120. So I added in these negatives because that is what's required, but it probably was a little, sounded a little fishy and not quite above board. Let's actually see what kinds of things we can do with this in terms of area. So what I want to show you is if we're actually dealing with, let's say the area goes like this. This area goes like this. This area goes like this. And let's say this one is always 5, and this one is always 7. So 5 and 7, 5 and 7. Okay. Yeah. All right. So, okay, now we're not just dealing with line segments. We're actually dealing with areas. Let's look at what's happening here. The principle, the one that that I kind of demonstrated a little bit, is this: the integral from a to b of f of x dx. I'm going to give you the principle first. I'm going to illustrate it with this again with an actual area going on so you can see it. Is equal to, now let's really pay attention to these limits. This is the main thing. Is equal to the integral from something plus from something to something plus the integral from something to something of f of x dx. Now, that something is from a to c of that plus c to b. Okay, so this is what I definitely want you guys to have in your notes. And the placement of these things is absolutely crucial. But once you have everything in the correct place, C can be anywhere. It doesn't have to be in the middle. It could be in the middle. It could be out here. It could be out here. It does not have to be anywhere specific as long as you have these things in this order. And I'm going to show you why. Now I'm going to need to unfortunately erase this so I can have enough space to show you. But let's go through these examples using this first. And remember, we're going from A to C and then from C to B. And that should get us A to B as the final result. So keep this written down, and I will now go through examples of this and show you that in any case, it doesn't matter. All right, so looking at from A to B, the area is clearly 12, but let's actually write this out. So the area from A to B is the area from A to C. I'm just gonna make it FDX because parentheses are annoying. Plus integral from C to B of f of x dx. Okay. And let's see what that gives us. So the integral from A to C would be 5. That's the area under this, and that's 5. And then the integral from B to C is 7, and so that should just give us 12. This is the easy example. Again, in both cases, we're going in this direction. Let's look at this case. Again, we're trying to find the area from A to B in every single case. So it should be from A to C of f dx plus the integral from C to B of f dx. Okay, now we have to be aware of which one of these is going in the wrong direction. So let's think about it. If you start at A and go to C, are you going backwards? And the answer is yes. So again, remember there's two ways you can think about this. Either you can think about the fact that you're going backwards, or you can actually say because A is actually bigger than C, or it's to the right of C, then this is not written correctly. What we should instead say is negative the integral from C to A of f dx plus, and then wait a second, from C to B is fine. That's correct. C is to the left of B, so you can start at C and go to B and you're going in a positive direction. That's fine. From C to B of f dx. Okay, and that should give us, this little area is going to be -5. And then from C to B, well, that's 12. And so that should give us 7. And that is, in fact, the area. Let's try this last one. Again, can you identify, of the two, from A to C, f dx, and from C to B, f dx? Whoa. Crazy shenanigans. Okay, can you identify which of these is going in the wrong direction? Okay, yes, C, in this case, is bigger than B, or it's to the right of B. That's not, doesn't work. You can't start at C and go to B if you're going, if you're always going to the left. If you're always going to the right. Or you can think about it as this is going in the negative direction, which is wrong. It should be going in the positive direction. Either way, this one should be subtracted from the area from A to C. So the area from A to C is 12. And then you're going to subtract this area off. Just like over here, we had the area of 12, and then we subtracted this off because it was going in the wrong direction. Here, they were both going in the same direction, so it was fine. We just added them together. But if we're ever going the wrong direction, we have to subtract it off. So we have the positive 12, that's from A to C. That's fine. Direction is fine. But then from C to B, we actually should be going the opposite direction. So we need to change this to have a negative out front, put a B here and a C there. We're allowed to do that by the rule we have. And so in other words, this should be 12 minus the area from B to C, which is 7. So the -7 comes in here, and that gives us an area of 5, which is in fact the area. So again, I want you guys to have written out the rule here, and I want you to understand that that this is an extremely useful rule, and it doesn't matter where C is as long as you get this order correct. From A to C and then from C to B, that always gets you from A to B, regardless of where C is. All right. Finally, just to review some things that we've learned. One of the main ones is this one right here, where if we are switching the direction of the bounds, or if we're just switching the order of the upper and lower bounds, we do need to put a negative out front, and that is one of the ways in which the net signed area, which is what we're finding, can be less than 0, is if the upper and lower bounds have been switched. In other words, we're going in the incorrect direction. Another way that can happen is if our y values are below the x-axis. Another one we learned is that we can split any integral up into 2 parts, and the middle point doesn't have to be between a and b. And then finally, if we are actually going to find the total area not signed at all, what we need to do is we need to take the absolute value and integrate that. And that actually, we're not actually going to do that yet. That involves finding every place where something is negative. So we're not going to do that yet, but that's what that is.